example yesterday I have explained or not? If any buffalo, this buffalo example yesterday I have explained.
Yes, sir.
Yes or no?
Yes, sir.
Anyone?
Yes, sir.
Just take a look. This there is 1000 buffaloes. This example I have explained or not?
Yes, sir. You have explained.
Anyone, please respond.
Yes, sir. You have
You see on
explained.
the screen there are 1000 buffaloes. An example is there. Have you discussed this example? Anyone?
Yes, sir. Yes, sir.
Am I audible or not?
Yes, sir.
Yes, sir. You are audible.
Am I audible? Please raise
Yes,
your
sir.
hand if I'm audible. Okay, you please just check whether this topic has been covered or not. The example of 1000 buffaloes. You can unmute yourself. Anyone?
We covered it.
Yes, sir. It has been
Yes, sir.
discussed.
Yes, sir.
Anyone unmute and tell whether this we have covered or not. This example of 1000 buffaloes.
Yes, sir. It has been discussed.
Himanshu,
Yes, sir. It has been discussed.
Ayush, Paul.
Yes, sir. It has been discussed.
This example we have covered, discussed or not.
Yes, sir.
Yes,
Yes,
sir.
sir.
Anyone, please respond whether this topic has been covered or not. You can unmute. Okay, speaker is not working. Okay, just a minute. Now it's okay. Am I audible?
Yes, sir, you are
Yes,
audible.
sir.
Yes, sir. You are audible.
Yes, sir.
Am I audible or not?
Yes, sir. We
Yes,
can
sir. You
hear
are
you.
audible.
You please raise your hand if I am audible or not. Okay. Okay, let me start once again. Okay. If I'm audible, then it's okay. So let me repeat what we have discussed so far. So the IoT always talks about 4D technologies. One is data technology. Okay. Then so as far as learning is concerned, we have supervised learning and unsupervised learning. In supervised learning, the developer or the user has to train the device according to his requirement. But unsupervised learning, we don't have any training as such. And Internet of Things is nothing but emotions of things. So you have to make your devices smart, and because these devices are connected with the sensors, they gather information either in analog or digital form. Okay, so we have plenty of such examples. For instance, driver alert system in automobiles or cars. Okay, so if the driver is drunken, so there will be a sensor, alcohol sensor. Okay, so if the percentage of it will set some threshold is set. If the percentage of alcohol is some greater than some threshold, then the ignition will be switched off. Okay, so that is what driver alert system. Even when the speed of the vehicle goes beyond some threshold, then it will send a notification or an alarm to the nearby traffic or a poll gate. Okay, toll gate. Okay. So the sensing devices, they gather information maybe in a form of analog or a digital. Okay, so there will be a comparator to compare with the threshold, then the decision will be taken. So analog sensors, it will tell about how much percentage of alcohol has been consumed, and the response is given by the sensor digitally in voltage, because the signal is in the form of either current or volt or voltage. So it may be logic 0 0 volt, or logic 1 maybe 5 volt, or maybe 3.3. Okay, depending on the type of devices that we're using. Okay, so digital sensor always gives the result as 0 or 1, or 0 volt or 5 volt. Okay, whereas analog sensors, when you say alcohol sensors, it will tell in percentage amount of alcohol consumed. Okay, and that analog percentage is converted into a digital form. Okay, so there are 5 layers in any IoT architecture. Okay, so layer 1, we all know layer 1 has got the sensors to sense the signals, and whereas analog or digital sensors, and a widely used internet device in every home is Wi-Fi router. Okay, so router is nothing but established to connect two different networks. Okay, so I'll tell some basic elements of the network also. And ISP is nothing but internet service provider that we all know. Okay, so from the LAN cable to the Wi-Fi router, then private area network, and then through mobile phone. This is something that you might have done from your hostels also. So you can access internet directly through Wi-Fi, okay, or indirectly through mobile phones or laptops. Okay, by creating some hotspots. So because we talk about connecting devices, and there may be millions of devices to be connected, and every person on an average has kept 7 devices, and it may go 20 devices. So it's not feasible to provide internet to each and every device. So then we require a concept called router, what we call IoT gateway. Okay. A simple example is there. For instance, there are 1000 buffaloes are there. Okay, so in a dairy farm, and you want to monitor the buffaloes. Okay, and then what you have to do, you have to divide these buffaloes into different sections. Okay, for instance, buffaloes, 1000 buffaloes into 5 departments, and every department have 200 buffaloes, and in one department again you divide into 5 sections, and in every section there are 40 buffaloes. Okay, now what you will do, you provide internet connection to one buffalo out of 40 through a Wi-Fi router. Okay, and the other will directly access it through this router itself. Okay, similarly, what you do, you have a mobile phone, you are using a data pack of a Jio or Airtel, you mobile data on, hotspot on, then you can use your laptop or any other device. Okay, that is in the vicinity. Okay, so your mobile phone will act as a gateway. Okay, which acts as an internet service provider to the other devices. Okay, so here also the same thing. It is not feasible to connect internet with every device directly, so you do that through some gateway. Okay, so there is nothing but your router. So you connect internet only to one buffalo, and the rest remaining buffaloes in that particular section will be accessing that particular router itself. Okay, so I will connect internet only to one buffalo out of 40. Okay, so that acts as a Wi-Fi router, and so 20 devices per buffalo will be connected with internet directly, and by this the entire 975 devices are internet enabled devices, but indirectly. Okay, so you are using hotspot and your laptop through your mobile phone. So your mobile phone, you are using mobile data and hotspot, then that is coming to your laptop. Okay, so that is an indirect internet enabled device. Okay, and 25 devices are also internet enabled devices, but directly. Okay, because it's not feasible to provide direct internet to each and every device in the network. So in this one section, there are 40 buffaloes handling one router. Okay, 40 devices you can consider with connected with one Wi-Fi router. Okay, and that one router maybe Wi-Fi, maybe Bluetooth or a LoRa or a Zigbee, depending on the type of the network. So for instance, 40 means 10 buffaloes are in the Wi-Fi per private area network. Another is working on Bluetooth. Another 10 is working on LoRa PAN, and another is Zigbee. Okay, so we have heterogeneous networks. Okay, so an IoT gateway is a heterogeneous combination of different homogeneous wireless networks. So this you have to remember that a gateway, especially an IoT gateway, is a heterogeneous combination. You see, different Wi-Fi is there, Bluetooth is there, LoRa is there, Zigbee is there. Okay, so it's a heterogeneous combination of different homogeneous wireless networks. Okay. So as far as the different layers in the architecture is concerned, the first layer is nothing but the sensing devices or the sensors. Then we have a network, the wireless sensor network. Then in order to connect that sensing device to the cloud, you require an IoT gateway, because there is not one device, there are many devices are there. So that's why gateway is required. So from the gateway, it will connect to the cloud. From cloud, you can access through your mobile phone. Okay. So there is a sequence that generally follow in any of the IoT applications. Let us take some example. So for instance, you have to make your home aquarium as a smart aquarium. Okay, so how to make it smart in the sense means you have to feed the fishes in the aquarium by using a smart feeder box. The feeder box is there, but you have to add intelligence to that. You have to make it smart, and it has to feed fishes in the aquarium morning at 6 a.m. and evening at 8 p.m. Okay. So now at 6 a.m. it sends a notification to the user to drop the feed. Okay. So as soon as the time is 6 a.m. it will send a notification through SMS or an email through the user. Okay. And it waits. If the user is seeing the notification, then he'll do manually. Otherwise, it waits for 5 minutes or 10 minutes. If the user is busy, then the feeder box will drop the feed and sends a notification to the user. Okay, so this is what the intelligence has been incorporated. If the user is not doing it, then the feeder will feed the food to the fishes in the aquarium. Okay. So now the question arises where the decision will be taken. Okay, at what level? Okay. So let us see the scenario that we have. So their places of decision making is if internet is available. If internet is available, then cloud is required. If internet is not available, then the device has to handle. So decision making is one at the cloud and other is as the device, depending on the internet. Okay, if you have an internet, then clouds will do the decision making. If internet is not available, then the device has to make the decision. Okay, it is similar to what in a family. If father is there, then he has to make the decision. If is 6:30. Okay, so if internet is not available, means what? The device has to take the decision because the cloud is absent now. Okay. So this is a scenario. Similarly, for instance, if you want to plant water, okay, so if you want to pour water on your plants in your garden or in a balcony, okay, so you have to make that plant as a smart device. Okay, smart plants. For instance, your plant is there in Hyderabad, okay, and you are there in the Ranchi. Now, how you are going to pour water? Okay. Now there's a sequence. Now your plant is connected to the gateway. Okay, so gateway is connected to the cloud, and from the cloud you are accessing through your mobile phone through WhatsApp. Okay, so this is a scenario. This flow will be there in most of the IoT application. Okay, so the device sensing devices are connected to the cloud through IoT gateway, and from IoT cloud, from the cloud, you are analyzing the data or the decisions. Okay, so you cannot connect directly with your device because you are in the Ranchi and your plant is there in Hyderabad. So you are not directly connected. So you are connected through cloud itself. So let us see some scenarios. Okay. Now I am free, so I'll pour water. Okay. So then cloud, IoT gateway, plant, and water sprinkler. Water sprinkler is a smart device where sensors are connected. Okay, so that will be sprinkler will be on and off depending on the signals. Okay, so if I am free, then I'll pour the water. If I am busy, okay, I'm busy, then cloud will understand that the user will be busy. Okay, then it will send a notification to the gateway, then plant, then the water sprinkler. Okay, so in this case, in both the cases, internet is there. In the first case, the user is free. He can directly pour water. Okay. Or what he sends a notification to the cloud. Just pour water. Okay. For instance, you are in the I am in Ranchi and the plant is in Hyderabad. Okay. So what I'll do, I am free, so I'll send a notification to the cloud to pour water. So the notification will be sent from the cloud to the IoT gateway, and IoT gateway is connected to your plant, and then it is connected to the water sprinkler, so it will be on. For instance, I am busy now. So who is going to send the notification to the cloud? So the cloud will understand that the user is behavior, behavior that he is busy, he or she is busy. So what will send? It will send the device automatically to switch on the sparkler. So it again goes from IoT gateway to the plant to water sprinkler. Okay. So if there is no internet, then there is no cloud. So now what is available with the IoT gateway, plant, and water sprinkler? Okay. So even if IoT gateway is not working, then what is available is plant and water sprinkler. Okay. So these are the scenarios as far as the availability of the decision making, whether decision making is done at the device end or at the cloud end. Okay, so if the internet is there, if the user is free, then just send a notification through mobile phone to the cloud to just switch on the water sprinkler. So it'll from the IoT gateway, it will go to the plant connected with the water sprinkler. If the user is busy, then the cloud has to take the decision. Okay, if there is no internet, there is no gateway. Okay, so no internet means there is cloud is not there. So I have got an IoT gateway connected to the plant and water sprinkler. Even if there is an error, something wrong with the gateway, then we have left with plant and water sprinkler. Okay, in this case you have to, there is no other option. Okay, so you have to do it manually. So let me. So this is a picture that I have shown the IoT as a big picture. Okay. So always remember that the cycle or the flow. Okay. So your devices are connected to the IoT gateway, from IoT gateway to the cloud, then cloud to your mobile phone or laptop from where you are analyzing. So you are not connected directly with the devices. Okay, if it is a single device, then it's okay. If you have multiple devices, then you have to connect to the cloud. Okay, so you see here there are multiple sensors are there of carrying on different signals. So it may be in a voltage form or a current. Then it will do a sort of serial transform using interconnection network, or what you call integrated circuit. So these are nothing but serial communication protocols. So serial peripheral interface, we call it as SPI. Okay, so bit by bit transfer it takes place because the devices are communicating now. Okay, so how the data is sent? So serially is this transfer from machine to machine, and then you see the transfer takes place because the data that is collected here has to be sent to the cloud. So it will come through gateway itself. Okay, so through gateway, so using communication protocols, so serial communication protocols through I2C or SPI. Okay, so bit by bit transfer will be communicated. So here you have got your microcontroller Raspberry Pi. Okay, so from here it will directly go to the cloud because here you have got the IoT gateway. Okay, so this is your IoT gateway, and then it goes to the cloud. Okay, then your mobile phone or laptop. Okay, so this cycle is generally followed. Okay, so here in IoT gateway I mentioned, so the gateway or this Raspberry Pi may be at this location. Okay, because the Raspberry Pi or microcontroller can also act as a gateway. So this is the connectivity of the IO. Connectivity sensors are connected. Okay, so we people have got many devices, so they are connected. These devices are sensing devices. So through IoT, people as well as devices are connected through some connectivity. Okay, and here you see the number of devices are more than the number of users. So that figure I have shown in the last class also. So let me tell you some fundamentals how the communication is actually taking place. Okay. So because some network fundamentals is very much required when you're learning basics of IoT. So I'll just give a general idea, okay, which will be used later also. So in the in networks, we have one of the important model. Many of you might have heard OSI model, OSI reference model. Okay, so they are generally called as open system interconnection model. Okay, so this open system interconnection. Okay, so this is a fundamental model that we have how one machine is going to communicate with another machine. So they use this communication takes place through this OSI model itself. Okay, and we have 7 layers on this. 7 layers. So one computer is going to communicate with another computer through these layers only. Okay. So what are the different layers we have? So at the bottom we have physical layer. Then we have data link layer. Then network layer. Then transport. This is called as session. Okay. Session layer. Then presentation. And finally at the top, as a user, we have the application. Okay, so there is a fundamental model that we have. Okay, so OSI model, open system interconnection model. So if the machines are communicating through this model itself, reference model. Okay. Now, when we talk about connecting devices in a network, so we have some physical network devices as well. Okay, so in the physical layer, we have hub or what you call repeater. Okay. And then in data link layer, we have a bridge because the data has to be communicated from one system to another. Okay. Or we call it a switch. In the network, the gateway, IoT gateway is nothing but a router itself, a sort of router. Okay. So this is gateway. Okay. So because we are talking about connecting devices where there's a different devices are to be connected through the network. So in order to create a network, we require some components or what you call network devices to connect one system with the another. Okay. So we start with this layers. There are 7 layers are there, and we start with one we call hub. Okay, hub is nothing but also called as a layer 1 device because it is in layer 1. So it's a layer 1 device. So what it does actually, uh, for instance, this is my hub. Okay, and some computers are connected. Computer A, computer B, one computer here, one computer here. Okay, so you can connect like this. Okay, what you call hub. And now so so this hub is not an intelligent device. Why is so not an intelligent device? Okay, so for instance, A wants to communicate with D. So that message, what it will do, that message will be broadcast to all other machines connected to this particular hub. Okay, so whatever the devices that are connected, so it will be broadcasted. Okay, so that's why it is also called as a broadcast device. So A wants to communicate with D, that message will be broadcast to all the machines that is connected to this hub. Okay, and it is generally uses half duplex scenario as far as communicating is concerned. Half duplex means what? If A is a sender and D is a receiver, then the message at a time will go from A to D only. Okay, not to time when you are sending message A to D, D cannot simultaneously send a message to A. That is not possible. That is possible in duplex. So in half duplex, at a time only one channel is active. Okay. For instance, you want to communicate A with D. So whatever the channel is there, so it is only one way it is communicate at a time. So A will send to D. Okay, so once the message is received, then only D can send through B. Okay, both cannot communicate at the same time. So if that is there, we call it as a full duplex. Okay, so now this hub is actually, nowadays we are not using hub, but as a network device, you must have a general idea. Okay, so it's not an intelligent device. It just broadcasts the messages from to all the systems that are connected, and it is a LAN device. And what at a time only one message can be passed, and so that's why it is called as a uh, single collision domain. So when I say single collision domain means so only one path is there from A to B. Okay, so only one path is there. Okay, so there is no collision as such. Okay, you cannot when B is communicating with C, only one path is there. Okay, so assuming that there is one door is there for communication. Okay, so that is why it is called as a single collision domain. Okay, so if A is communicating with D, simultaneously B has to try to communicate, and there will be a collision. Okay, because there will be one door only for communication. And we have one concept called MAC address. So this does not store MAC address. Does not store this MAC address. So MAC address is actually a physical address. Okay, we call it as a media access control. Okay, media access control. Okay, so there are MAC address and IP address. I'll discuss that later, but for the time being, just assume that there is a physical address for the device and is called as a MAC address, and this hub does, because it is not intelligent, so it does not store any information. So that's why it does not store any MAC address. Okay, so nowadays we don't use this hub anymore. Okay, so rather similarly here I mentioned repeater also. Repeater so repeater is also a layer 1 device. Okay, and it actually, what it does, it amplifies the signal. Amplifies, or you can write regenerate the signal. Okay, for instance, we generally use that coaxial cable in networking. We call it as a 10 base 2 cable. Okay, you have a LAN port in your laptop and all. No? That LAN port, that is some. So so that LAN port, the cable that we use, that is considered as a 10 base 2 cable. Similarly, we have 10 base 5 also, but in most of the cases we use 10 base 2 cable, and it generally covers or sends message up to 185 meters. Okay, for instance, you have sent a message through LAN cable through this cable, okay, to 185 meters, but you want to send beyond that. So then what you will do, you will add this repeater here. So it amplifies the signal. Again, it further sends to 185 meter further. So again, you want to send further distance, then again you add a repeater. So this signal will be regenerated again and again further 185 meters. Okay, if you're using a coaxial cable of 10 base 2. Okay. So the repeater is generally regenerates the signal, or what you call amplifies the signal. Okay. In hub also we have in hub we have active hub and passive hub also. Okay. Active hub and passive hub. So active hub means it generally requires electricity. उसको ऑन करने के लिए पावर चाहिए, ठीक है. So that is why we call it as the active hub. Okay, and it also amplifies signal like repeater. It amplifies signal, right? A repeater, okay, or regenerates signals. Okay, but in passive does not require electricity. Does not require electricity. Okay, and does not simplify amplify signal. Does not amplify signal. Okay, so this one more difference that was there as far as whether it's an active hub or a passive hub is concerned. So remember that active hub generally requires electricity to for its functionality, and it also amplifies signals. But in case of passive hub, it does not require any electricity, and it does not amplify any signal. Okay. So as far as the repeater is concerned, we use the 10 base 2 coaxial cable. It generally has a range of 185 meters. So if you want to go beyond that, then you keep on adding this repeaters. Okay. So nowadays we are not using all this devices. Rather, we generally use, because we call it as a RJ45 cable. That you're using to connect your laptop through your LAN port. So we call it as a RJ45 connector. ठीक है, जो LAN cable आप laptop में connect करते हैं, they're generally RJ45. Okay. So here we have some network devices like hub and repeater, that layer 1 devices. So nowadays we are not using all this. On the data link layer, so in the data link layer, so in the data link layer, I mentioned that we are using bridge or a switch. Okay. So that is a layer 2 device. So when I say bridge, it is something like, for instance, you are in one place and you want to move to another place, and in between you have a river. That case. Okay. So we have a scenario, for instance, when I talk about a bridge, there is a river and you are in this point and you want, so this is your river, so there is a bridge here. So what this actually bridge does is help you to move from this point to this point. Okay, so you are bypassing this river. So bridge also does the same thing when you connect you. Okay, for instance, this is one computer, this is another machine is connected, this is a C is connected. Okay, now let me extend this. A, B, C, D is another machine, E is another machine. Okay, so this following a bus topology. Okay, G. Okay, so this is a scenario that is in a bus topology, the machines are connected like this. So if you use a hub, it will broadcast any message is there, that message will be broadcast to all the systems. Okay, because it is not intelligent, so there is a broadcast system. Okay, but what you do, you connect this portion of system and this portion of the system. Okay, so this one section, there's another section with this bridge, and it will have two ports because this section will have one port here, this section will have one port. Okay, so this is called as a bridge. Okay, now what this bridge actually does, if you compare with the hub, so this bridge is a little bit intelligence. It has got some intelligence. Okay, it has got some intelligence. Kaise? It actually inspects the incoming traffic and decides whether to forward or reject. Okay, and it checks source and destination MAC addresses, because we have a MAC addresses for the devices that are connected. And for instance, there's a bridge having two ports. This section has got port 1, this section has a port 2, and it actually maintains a table. Okay, it maintains a table and we call it as a bridge table. Bridge table, and it has got two sections because there are ports are there. So we can write port number and here MAC address. So in the hub, we don't have a concept of MAC address. Now here it has got the capability of storing information, so that's why it is intelligent. So physical address is there. Okay. Now, for instance, a computer at point A here wants to communicate with F. Okay, and for instance, this is your fresh network. First time you have connected all these computers through this bus topology. Now I want that A should communicate, this A should communicate with this F here. So first time A doesn't know where F is. So whatever the message is there, this message to this port, it will first broadcast to all the systems that are there, similar to what we have discussed in hub first time, because this bridge table is empty now. There is a fresh connection and A computer wants to communicate with F computer in this topology. So what it will do, the message will be broadcast to all. Okay, so I have from port 1. Okay, so port 1 is there and connected to computer A. So now it is A is there. Now it is communicating with F, but it is in port number 2. So I'll write 2 and F. Okay. Now let's say A wants to communicate with C. Okay. You see whether A and C is there in the table. A is there. So it is with reference to port A, but C is not there. So again, what will happen? Again, it will broadcast to all. So when it is broadcasted, A is there in port 1 and C is also there in port 1. So in the next time when A wants to communicate C, there it is not going to broadcast because this is there already in the table that both A and C are falling in this left hand section, left side of this bridge, and this is right side of the bridge. Okay, so like this, all these device machines that are connected will be accommodated in the corresponding bridge table. Okay, so the machines that are connected to, because initially if they are not connected, it will be broadcasted, then it will establish a connection and the information will be stored in the bridge table. So A, C and B will be there here, then F, G and D will be there. So now once the information is stored, so it is a storing devices, but a hub is not a storing devices. So the MAC address is not stored in the hub. So that's why it's not intelligent, but bridge is somewhat intelligent as compared to hub. So it's start information about the MAC addresses of the devices that are connected. Okay, now once this table is ready, now for instance, A want to communicate with G. So A is there in port A and G is there in port 2. So that port 2, that message directly will go to the G and it won't forecast to all the systems in the network because it is already mentioned in the bridge table. Okay, so what it does actually, first time it will broadcast. Okay, but later if the bridge table has got the complete information, then it will do unicast. Okay, so in this scenario, you see the bridge table is complete. All the information of the MAC address of all the machine in the network is there. Now, if A wants to communicate with B, it directly communicate with B, and the message won't go to other systems. Okay, so that's why initially it will be broadcast, then later it will be unicast. So initially I started with broadcasting. When this information is stored, now it will behave intelligently that no, A is sending an F means information is there. A is in port 1 and F is connected to port 2, so the message will send A to F. So that is what we call unicast. Okay, so so in this way, this bridge actually monitors the traffic of the messages that are there as far as the between these communicating devices are concerned. If A wants to communicate with F, so A will communicate with F. Okay. So that's why it says that inspects incoming traffic and decide whether to forward or reject. Okay. So and it'll check the source and destination MAC address. And finally, when this bridge table is ready, then you know where the source and where the destination is. Okay, so this is also one of the important network element we have, and it is used to connect network segments or LAN segments. Okay, so it is used to connect. क्या connect करता है? Connect network segment. See, this is one segment, this is another segment. So you can call it as a network segment. So used to connect network segment, or you can write LAN segment. Okay, because you see this is one particular segment on the right hand side, there's another segment on the left hand side. So port 1 and port 2 of the bridge are connected. And here you see in that bridge there are two doors are there. So that's why it is called as two collision domain. Okay. So we call it as a two collision domains. Okay. So A will send a signal from port A, from port 2 it will pass it out. Okay, but in hub it's a one collision domain, one door is there. Whatever you want to do, you have to do with that door. So that's what is called single collision domain. But here we have two doors are there, two ports, so it is two collision domain. Okay. So there is a general information about bridge. Okay. Now the extended version of bridge is nothing but switch. So these are something nowadays we are using: switch, router, gateway. These three we are using nowadays. Okay, so we are not using this hub and all. So bridge also probably most of the cases we are not using, rather we are following switch. Okay. Now in your hostels also, in department also, you'll find switches are there. Okay. So switch is nothing but it is also intelligent. Okay. So it's an intelligent device, and it is actually an extension of bridge. Extension of bridge. Okay. Now let me draw. For instance, this is a switch. Okay. So physically, if I ask you to identify which one is a switch and which one is a router. Okay, let me explain switch, then I'll come to router. Okay, so ये आपके पास switch है and you are connecting some computers A, B, C, some machines you have connected here. Okay, so in this E, F, G, so some computers you have connected to the switch. Now in this switch, every computer is connected to every other computer. So they have got the dedicated path. A is connected with E, A is connected with F, A is connected to this is also connected to this is also connected to this. Every computer is connected to every other computer. Okay. So that's why here it uses the concept of full duplex. Okay, in half duplex only sender can send a message to the receiver, one time sending message, but here same time you can send and receive messages. Okay, because if A is sending a message to G, okay, similarly G can send a message to A simultaneously. Okay, so we have so many paths are there. Okay, multiple paths. Okay, so here in this since it is an intelligent, so it must have a storing capability. So what it stores actually, it actually, so like in bridge table here also we have a table called cam. What is this cam here? Cam is nothing but, we call it as content accessible memory. Content accessible memory. Similarly, we have discussed a bridge table, so it maintains some records. So this also content addressable memory of the switch. Okay, so what it maintains? So it maintains all the ports. कितने ports हैं यहाँ पे? 8 ports हैं. So switch 1, 2, 3, 4, 5, 6, 7, 8. So this is nothing but like this: 1, 2, 3, 4, 5, 6, 7, 7. For instance, 8 ports are there. हर machine का अपना port है, ठीक है? 8 ports. Now, for instance, there is a fresh connection we have. No communication yet started because so this contains the MAC address. So as we have discussed in our bridge table. Okay, so the devices are connected with the MAC address. Okay, so now A wants to communicate with any of the machine, it will do a broadcast. Okay, so when it do a broadcast, so A wants to send a message to G, but that message will go to each and every machine. Okay, so A is connected to port 1 is connected to A. Okay, and it wants to communicate with G. Okay, so G is there in port number 7. 7 में कहाँ है? यहाँ पे G लिखिए, ठीक है? So now initially it will broadcast. That message will go to everyone. Okay, so as soon as G sends an acknowledgement to the A, okay, then the connection between A and G is established. So others will reject the message because that message is not for others, but they have received it, but it will drop that particular information or a message. Okay. Similarly, next time A wants to communicate with E. So this is the first time no information here is in the table. So E is there in port number 5. So E will write. So like this, the entire table will be filled. So once the table is filled, so that's why we call it as here also first time broadcast. Okay, then unicast भी हो सकता है और multicast भी हो सकता है. Okay, so it depends on the situation. Okay, so unicast or at a time we want to send message to G and H, so that is there in the information in which port it is there to directly you send that particular message to multiple machines. Okay, unicast means 1-to-1. A will send to F only. So information this once this table is filled, there will be no broadcast. So direct based on the addresses the machines can communicate. Okay, so that's why it is first. If it is table is empty, then it will do broadcasting. Once it is filled, then you can go for multicast, sending one message to 2 or 3 machines at a time, multicast, or one machine to one machine, unicast. Okay. Now here, since there are multiple doors are there, so it is called as multi-collision domain. So we started with single collision domain, 2 collision domain, then we have multi-collision domain. Okay. So here, as far as the number of ports are concerned, there are actually 8 port हो सकता है, 6 हो सकता है, 24 port maybe. At most you go 48 port switch. So the switch is there in your hostels also. Okay, where you are connecting with your local LAN in each and every room. So each and every room is connected to this switch. So हर lobby में आपको switch मिलेगा hostel में. So it may be a 8 port or 6 port or 24 or 48 port switch. Okay. So now here, if you talk about speed, वो 100 Mbps हो सकता है और sorry 10 हो सकता है और 100 Mbps तक जा सकता है speed. If you talk about speed, the data rate, ठीक है? So megabytes per second. So 10 megabytes per second से 100 megabytes per second. Okay. So this is 10 megabytes per second if it is wireless. So 100 is if it is wired. So there's a range, this speed of data rate is depending on the type. Wireless, then it will go 100 megabytes per second. If it is wired means it will go 100 megabytes per second. Okay. So then further we have different types also, store and forward switch and cut through switch, fragment, adaptive, plenty are there. Okay. So it's not possible because that will become a network class. Okay. So this is the fundamental thing that you remember. Okay. Then so we have discussed the physical layer device, the data link layer device, okay, like bridge or a switch. Next most important that we use is router. Okay, so router. So we'll stop here because the router we'll discuss next class. Okay, so these are some of the fundamentals are there. Okay, so you must know this because we are talking about Internet of Things and these terms will be keep on coming. Okay, router, IP address. Okay, gateway. Okay, this router itself is a gateway actually. And what this let me, I'll continue in the next class also, but let me tell you. So there are two different networks. Okay, so this is switch connected with several machines. There's another switch. There's another switch connected to all other machines. So this is one network, this another network. So this network and this network will be connected with a router. Okay, so the switches, hubs, bridge and all, they are used to create the network. But this router will help you to connect the network. Okay, so that is the difference. Okay, so we'll continue this in the next class. So if you have any doubt, you can ask me. Can't believe it. इसको attendance कहाँ चले गया? So okay, we'll continue in the next class. Okay, thank you and take care. Bye bye.
Yes, sir.
Thank you, sir.
Thank you, sir.